Hello, ho ho ho, and welcome to Cracking the Cryptic on this little Christmas Eve, I think they call it, in some parts of Scandinavia. Now, talking of some parts of Scandinavia, Søren sent a picture of a cake that is for his son's birthday. Now, Søren was one of the extraordinarily high number of people who ask for a birthday shout out, and then let me just minimize my face. There we go. There is the cake for Søren's 11-year-old son. Søren is one of the, I think it's 20% of people who write to us for a birthday shout out don't include the name of the birthday celebratee, and Søren was in that category. And even, I think, Simon wrote back to him and asked what his son's name was. And Søren sent a picture of the cake instead, which looks great. And it's to prove the 1-to-1 ratio of cake to icing. We've even got 1-to-1 on the cake, unless by chance that's Søren's son's age. But happy birthday, Sørensen, if I may say so. That looks like Matilda's chocolate milk that's gone into the cake, which I know from my various trips to Denmark, and I highly recommend. Very good stuff. Anyway, congratulations to Søren's son. And yeah, that's all I'm going to say about birthdays. I'm going to quickly mention that on Patreon now, been some confusion about when it was going up, but we now have Simon's 3.5-hour videos solving all the 100 4x4 puzzles in this month's Patreon reward. So fascinating viewing. You get to watch 3.5 bonus hours of Simon over Christmas, or whenever you choose to fit it in, if you are a $3 and above patron who gets those videos. Great stuff there. Thank you so much to Skunkworks for that. Well done to everybody who's entered the competition, got the right answer. You will know if that's you. And everyone will know if it's you once we finally put together the Roll of Honour and publish it. What else is going on the channel? We've got, let me just size myself better there. There we go, that looks better. We've got, of course, all our apps on the links under the video, including all sorts of lines Sudoku, but no lines like these lines that we're going to look at today. We've got our merchandise and the Discord server and the catalogue of our puzzles and Sven SUDOKU PAD. Look at the links under the video. This puzzle, though, well, it's by the Pedaling Pianist. I have looked back into the archives. We have done the Pedaling Pianist on the channel 8 times, and when I use the word we, what I mean is not we, but he, Simon, has taken all of the Pedaling Pianist's first 8 puzzles, or 7.5, because one was a collaboration, puzzles on the channel, and I am pinching this one, and I'm going to have a go at it. So, what are the rules and this is going to be brutal, because I've seen those Pedaling Pianist puzzles and videos, and yeah, let's see what happens. Anyway, if you fancy having a go at it, check the rules carefully. I'll explain them now. Normal Sudoku rules apply. We'll be putting 1 to 9 in every row, column, and box. You will notice there are no given digits. If the digits at each end of a line are X and Y, then the first X digits on the line starting from X must sum to the same total as the first digits on the line starting from Y. So let's imagine we had a 4 here and a 5 here. Then the first 5 cells here would add up to the same total as the first 4 cells here. It's like X sums stuck on the end of lines that have to be matched. That's it. Well, it's not like it. That's exactly what it is. Now, there are a few caveats. X and Y need not necessarily be different numbers. Okay, well, that could have been a 4 is the upshot of that. And it could look like that in terms of the areas that add up to the same number. X and Y may not exceed the number of cells on the line. Well, okay, I think that's obvious. You couldn't add the first 7 cells on this line. Wouldn't work. Okay, those are the rules. That's all there is. No given digits, just a bunch of lines, which do cover most of the cells in the puzzle. I don't know what we're going to get here, but I am going to restart and say, let's get cracking. Okay, good luck if you're attempting the puzzle. I think this is going to be hard. So, we've got X sums on the ends of every line. So the these 5 cell straight lines. Yeah, okay, the end digits have to be, well, they can't be 5 because you'd be adding all 5 cells. The total from the other end would have to add all the 5 cells. You'd have to have a 5 on the other end. So it's less than 5. So I'm literally going to write 1, 2, 3, 4 into all of those cells now. Now, none of them can be 1 either. And that's because the X sum total from one end would be 1. It would be adding the first cell, which would be a 1. And that would be unmatchable at the other end. So now we've got a 2, 3, 4 restricted set. 3 and 2. Okay, what about okay, I don't know. What are the problems? Overlaps or underlaps? 2 and 3 would clearly work because you just have to make sure that, say, that total added up to that total. There's no difficulty with those numbers. 4 one end. What would happen with 4 one end? That would be adding those digits. This is a very interesting case to think about. Right, let's call the total of those digits X. If that was a 4, we're adding 4 plus X to get the total on this line. Now, how many digits can we add here? Only 2 or 3. So we're adding 2 or 3, which is a number lower than 4. That is a knowledge bomb, courtesy of Cracking the Cryptic. 2, a number that is definitely lower than X because it doesn't include all the digits of X. And we must come out with a number lower than the total of X. And that will apply to a 4 on any end of the line. And there we are. We've got a 2, 3 X-wing. That's weird. Isn't that weird? I don't know. Maybe it's just great. So that is an X-wing on 2s and 3s, which... And these lines are going to split into... is it worth colouring them? Sort of something like that, because one of these, this cell is either red or yellow, depending on which end is a 3. I don't know. Let's hold off. We'll do that if we want, if it might help later. What about this 6 cell line? Okay, this has got some of the same restrictions. You can't have a 6 on the end. And you can't have a 1 on the end. Now, this cell can't be 2 or 3 because it's seeing a pair of them. This is clearly what this line is doing here. So that is 4 or 5, and I wonder if the same trick applies to 5. If you put a 5 there, you're adding up those cells, and that's X and that's 5. Now, whatever you put here, you can't put 6 because the total would be different. It would be yellow plus the 6. You can't... If that's a 5, you'd be putting a number lower than 5. Yeah, again, you'd be adding fewer yellow cells and a lower starting digit. So 5 doesn't work there. That's a 4. There's our first number in the puzzle. And that is not yellow. Now, I think overlap is possible. This cell can't be 1. It can't be 5 for exactly the same reason that couldn't be 5. It can't be 6. It is 2 or 3. And we're adding either those two. You see, this is why I'm not colouring both ends, because the overlap cell there had to be one of them. Whereas if I was to colour these 3 cells, there'd be an overlap cell here, which is definitely yellow, but might not be the other colour. Now, I think those 3 could easily add together to... If that was a 2 and an... Oh, well, hang on. If that was a 2 and a 9, you'd get 11, which the only way of making it up doesn't involve a 4. If that was a 2 and an 8, this would be 10, which would involve another 2, so that's not possible. And if that was a 2 and anything smaller, it's utterly impossible, because 4 cells have to add up to at least 10. So that is a 3. Ah, okay. Unexpected. Now I am going to shade. Because I now know, oh, terrible choice of colour. I now know that the overlap cell is in both the threesome and the foursome. So 4 plus that plus those equals 3 plus that plus those. So if I do the algebra on that, I think that means that these cells, this one gets eliminated from both sides of that equation. These cells add up to 1 fewer than these cells, than this cell. Well, they can't be 1 and 2, because that would be a 3, and it can't be. On the other hand, they can't be as much as 5 and 6, because that would have to be a 12. So one of these is low, is a 1 or a 2, and the other one is higher. Yeah, I don't think we can go much further than that, and I can't really pencil mark that. So I'm going to have to find something else to do, which is a pity, because I've enjoyed working with those straight lines. This is an 8-cell line. But the interesting thing is it finishes in the same box. No, it's not. The interesting thing is that this digit can't be 2, 3, or 4. It can't be 1, because that digit would have to be 1. On this line, you could have 1 at both ends, but you can't up here. Because the ends don't see each other, so they can't both be 1. Here we can't have 1. So this is 5, 6, or 7. Well, I'm probably about to rule out 7. I can definitely rule out 8, because if you added up all those digits, you'd have to start with 8 at the other end to get to the same sum. So 8 is ruled out. I think 7 is ruled out on the same principles as I've been espousing for the other bits. So if those 7 were purple, this digit, which can't be 8, would have to be less than 7 and would be adding a subset, let's uncolour that, a subset of these digits as well as a lower number than the 7. That's right. So it just couldn't work. I mean, this is quite a complicated concept to grasp, but I think it's essential to the whole puzzle. Oh, sorry, I've just put in 7 when 7 is the number that comes out. This is either adding 5 or 6 cells. So what's the minimum they can add up to? If that is a 5, then we're just adding those. And we would need at least a 1 and a 6 here. So it'll be up to 12. And then a 2 and a 4 here, say. 14, 18. I'm not sure you couldn't get 1 fewer than that, but 18 seems to be the absolute minimum. Maybe 17. Why do I think it could be fewer? Because... oh, no, I don't think it could. I was trying to avoid putting a 1 in one of those cells, but then these will already be 5, 6, 7 at a minimum. No, I think it is 18 as a minimum. So the x sum from this end adds up to 18 as well. Now that's not going to get done in 2 cells. It could get done in 3. 18 is a minimum. Yeah, 18 is a minimum. So this could be a 3, but otherwise it's a 5 or 6. And I'm wondering, can it be a 3? How will that work? If those 3 cells are to add up to the maximum they could be, 3 and a 9-8 pair is 20. Yeah, that could work. Okay, that's a shame. I'd like to force that to be a 5-6 pair. I don't think I can. Now, what about this cockleshell line? Let's remember that I said 1 of 1 or 2 is in those cells. And the other one isn't. Right, we can't have a 1 on the end of this line because, for the same reason, that the 2 ends of the line see each other. How long is the line? 1, 2, 3, 4, 5, 6, 7 cells. So for the same reasons as we've been going through earlier with lines where the ends see each other, you can't have either the length of the line as a total or the length of the line minus 1. So these are not 7 or 6. They are lower than that. They're not 3 or 4. They're not 1. They're going to have to be 2 and 5. Oh, that's bizarre. I think this is right. I need to think about this again, though. Can they definitely not be 6? Yeah, it's the same principle. If you added up those 6 from a 6 at the top of this line, then this digit would be lower. It would be 5 or 2, in fact. And you'd be adding a fewer number of those cells and a lower number. Couldn't do it. Okay, great. These are a 2-5 pair, which feels a very strange... so 1 is the low digit in these cells. So, and the other digit, we are adding 1, and the difference of 4 and 3, which is 1, 2, to get this digit, which is 6, 7, 8, or 9. But the digit we're adding 1 to is 2 fewer than this digit, but also can't be 2, 3, 4, or 5. So that is from 8 or 9, and the digit up here is from 6 or 7. This can be anything it likes, weirdly. It's an overlap digit. It's just got no constraints on it at all. Anyway, now let's think about this cockle shell shape. 2, in one case we're adding just 2 cells, and in the other case we're adding the other 5. Oh, and the 2 cells we're adding include the number 2. Right, if we added those 2 and made this maximum, that's 11. Can we possibly add these 5 and keep it down to 11? 5, 1, 2, 1, 2 is 10. So we can. What about if this is 2? It looked easier to me for that to be the case. If that's a 2 and that's a 9, 11, then 5 plus 1 plus 2 plus 2 plus 1 is 10 again. So there is a degree of freedom there. Either way round. It seems to work either way round. And the total on that is 10 or 11, the n total. I mean, that's right, I think. So the second digit after, well, okay, the second digit after the 2 is an 8 or a 9 in one of those cells. And after the 5, how do we get the absolute minimum? I wonder if I'm missing something here. I don't know. I'm going to keep thinking about this one. After the 5, we're going to get, if that's the 5, I thought the absolute minimum was obtained by going 1, 2, 2, 1. No, that adds up to 11. Hang on. Have I done my maths wrong? If this is the 5, we're going to be adding these cells. Oh, in that case, it was 1, 2, 1, 1. Now, is there some problem with 1, 2, 1, 1? I don't think there is. I think there's a degree of freedom that way round. But, yeah, so in fact, that way round, this could be 8 or 9. No, that could be 8 or 9, because the degree of freedom is if the 5 goes this way around the shell. This is very hard to keep in your head, what's going on here. I hope you're following what I'm saying. And if you're not, sorry. I'm wondering if I should do something else, like maybe get more out of this 8 cell line first, the square. So if that was a 3, Well, no, maybe if it's a 6-5 pair, maybe that's actually worse. Ooh, if it's a 6, if there is a 6 here, that's a 1-7 pair. Right, let's try and rule out this being a 5-3 pair. That would be 5 here and 3 here. The 5 would be adding those cells, so x plus 5 equals, let's just colour them so I see what I'm doing. X plus 5 equals y plus 3. So these would add up. Now I reckoned that the minimum here was 1, 6 and a 2, 4 pair. 13 plus the 5 is 18. The 3 then would need to have 15 in these. I'm afraid that is doable. So all I've done is recapitulated my logic and found it to be sound. I don't know. I don't know that I can falsify a 5 and a 3 there. So maybe I'm going to have to move on to another line, which is galling because we were doing something here. Now this can't. Ah, that could be a 1 if that was a 1. Oh, that's distressing. Yeah, I don't know now. What else have I got left in this central column? 1, 6, 7. Well, this can't be 8 or 9, can it? That is 1, 6 or 7. In fact, 7 is too long. Well, no, it's not. 7 is possible because this line can have the same digits on both ends, but it can't be 8 or 9. So that is 8 or 9 in the column. I don't think that does anything. That cell is so uninteresting, unfortunately. Oh, no, that does something huge. This cell can no longer be 8 or 9 because of that 8-9 pair. Isn't that gorgeous? So this can't be the 2. There we go. That's the 5. That's the 2. We're colouring that little pair against this group. And I don't think we know the total. It's 10 or 11. But now this is quite restricted. If that was a 1-4 pair, we'd be up to 10 already. So with the 3 being there, that has to be a 1-2 pair. Now we're up to 8. These two, oh, they're going to have to add up to, they're going to have to be a 1-2 pair minimum as well. Of course they are. Sorry, I wasn't getting this sum done in the right bunches. I should have considered that pair and that pair. 11 is the minimum. So there we go. This is a 1-2 pair, and we know the order from the 2 we've got. That 1 fixes 2 and 1. That 2 fixes 3 and 2. You know what that's going to give us. That's 3 in the corner. That's 3 in the spot. Light losing its religion. Right, so we have got lots of cells in the grid now. There's a 2 in one of these 2 cells. Now, if it was those 2 digits, which would add up to 6, 7, 8, or 9, could we match that at this end? Not with a 1. We were not allowed 2 or 3. And if we put a 4 in here, it's going to be too much. These are going to have to be a minimum of 1, 4, 5, taking us up to 14. So that can't be a 2. We placed the 2 in the middle box, thanks to the rule. This is, I was going to say it's not a 1, but that is not, well, it's not a 1 because there's a 1 in one of these 2. This is 6 or 7. Now that's very interesting. That is very interesting. I might be, I was going to say I might be about to allege it can't be a 6, but it can be a 7. But I'm going to change my horses in midstream and allege that this is the same digit as that. And here's what I base that on. If this is a 7, it's adding all the cells on this 7-cell line. That has to be a 7 as well to do the same from the other end. That's clear. If it's a 6, it's adding all those cells plus the number 6. Now the number this end If it was lower than 6, would be falling into the trap that we keep finding. You'd be adding a fewer number of cells along the line and a lower X digit at the start. So that wouldn't work. So if this was a 6, this couldn't be 5, 4, 3, 2, 1. It clearly couldn't be 7 because that requires a 7 at the other end. So it would have to be 6. So these two are exactly the same digit, 6 or 7. And frankly, it doesn't matter what else we put in the line, this relationship will be fulfilled. As long as we keep those two red cells the same, that's done. That line is useless now. That's so strange. It doesn't even feel really plausible. There's a 2 in one of those two cells, bit of Sudoku, just to, oh, that's a 2 by Sudoku. That's a very interesting number because of the 3 possibility. Right. If this was a 3, the maximum these could add up to now is, I reckon, 14. Didn't we work out that the minimum total for these, whether that's a 5 or a 6, is 18? We did. That is not a 3. That is 5 or 6. There is a large degree of overlap here. Well, in fact, let's paint it. We'll go orange versus purple. No, orange versus the green colour. Those, okay, all of those cells are definitely included, and in one case, one more cell is included. Now, we should be able to equate the outies, I suppose. If this one was also orange, those 3 can be just ignored from the calculation. Then these 3 have to equal the total of those 3. There's no way for that to happen. If that's a 5, these add up to 7, that would be a 6. These would be 1 and 0. That's just nonsense. If that was a 6, these add up to 8. That's a 5. That would have to be a 2-1 pair, but this 2 stops that happening. So that is not the further overlap digit. This must be a 6. This must be a 5. And now these 3 digits add up to the same total as these 2, because they're the ones in the sums excluding these 3 common digits. So there's a difference of 3 between that number, and this one is lower. And it can't be 1 or 2. So let's put in 3, 4, 5, 6. This is 3 bigger than that, 6, 7, 8, or 9. And basically this, well, this whole square is complete as long as we maintain, it's a bit like the reds have to be the same, as long as we maintain a relationship of 3 between those, that's finished. The same is true here. Oh look, we've got a 6 in this box now. That's a 1-7 pair, and that becomes a 9. And now, well, we can do the actual full maths. 8 plus 4 is 12, 13, 20, and from the bottom 20. So we don't need that colouring anymore. We've done that line. And we've got a 3, 8, 9 triple here. A bit of Sudoku. Nice to get back to a bit of Sudoku after a bit of frenzied thinking. 5, 6 there. Ooh, we've got a 4, 7 pair on the end of this line. I will be turning my attention to that shortly. 4, 6, 7 here. Now, this can't be a 7 because that would be too long. If it was a 6, that would be a 6. If it was a 4, the total would be 4 plus 6 plus 7 is 17 plus that, which is at least 20. From the other end, this couldn't be more than a 5. So it's going to have to be at least a 4 that end. Now, if this is a 6, that's definitely a 6. So I think we've got 4, 5, or 6 on that end of the line. Now I'm going to go back to this line where we got a 4, 7 pair. Now, if we're adding 7 cells, we're going all the way down to there. If we're only adding 4, we're going to there. I don't know what this means for this number. Well, okay, what's the minimum? That could be 4 and 5 at a minimum, plus 4 and 7 there is 20. That is the minimum value. So could this even, this can't be 1, 2, or 3, or 5. Could it be a 4? And then these would add up to 16. Yeah, 4, 5, 7 in some order. Or even 1 something something. Yeah, so this is at least a 4. Could be a 6. Certainly could be a 7. How long's the line? 9 cells long. Well, yeah, we'd be adding those. I don't know. I think it could be a 7. That might be worth revisiting later. Oh, I've just seen I've got a huge problem here. That's because I've written the wrong numbers here. So let's discount what I said in this line. This is a 147 triple. Now we can't anymore have a 1 at the end because that can't be a 1 at the end. So this, and it can't be a 7, so it's a definite 4. There we go, that's better. In fact, I can fill these in as well. 7 and 1. Right, so this number is adding, this end of the line is adding 12 plus somewhere between 15 and 20 is the total. Oh no, that's 7 has fixed these as 6s. That's good. So this isn't a 6, but it's still somewhere between 15 and 20. This can't be 1, 2, or 3. Could it even be 4? Yeah, I'm sure it could. Well, could it? 4 plus 1 is 5. These would have to add up to 15. Yeah, that is possible. Okay. Not 6. 6 would take in the whole line. Now, can that be a 5? And I think we're back to the original problem. If that was adding 5, it would be taking all of those cells plus a 5, whereas this would be taking fewer than all of those cells and fewer than the 5. They couldn't match. So that is another 4. I'm still finding this relationship slightly complex. Now, 4 plus 8 plus that equals 4 plus those plus 1. There's some very obvious relationship. Oh, this can't be a 4 anymore. What is okay, those two are common digits that are being added in both versions. So I can totally discount those. They just don't matter. And this end is 4, 7, so that end is going to have to be 4, 7. Yes, look, it's obvious when you think about it. If that is one group of cells that adds to the same number, and that is the other group of cells that adds to the same number, you discount these, and these two add up to those two, so that is a 7 as well. That's so obvious, and it takes me so long to see that it proves I'm not an algebraist. Look, this now sees 7 and 6. This is somehow a naked 4. Oh, hang on. Am I absolutely sure this can't be 8 or 9? Why did I think it couldn't be 8? 1, 2, 3, 4, 5, 6, 7, 8. And that be a 7. Oh, it's the classic problem again. We'd be matching a fewer number of the next 8 cells and a lower digit against a higher digit and a larger number of the same cells. Yes, okay, so that is a 4. Naked 4, weirdly. There's a 4 in one of those cells by Sudoku. When will this puzzle turn into Sudoku? Now, can that be a 7? That's an interesting question. Because this is adding those 4 cells. The maximum it could get to is 28. 4 with a 9, 8, 7 set. Can you keep this down to 28? If that was a 7, plus 4 there is 11. These 5 cells have a minimum of 1, 4, 5, 6, 7. I think that's going to blow right through 23 plus 34. No, there's no way. So it's a 4 on the other end of that. And that's interesting. This is definitely worth marking. That yellow is going to equal the same as that blue end. So these 3 plus minus 7 equal those 2. That's quite difficult to come up with if I don't know. Oh, I've got 3 and 2. Oh, I'd forgotten to use the 2s and 3s in the end columns. Okay, I'm just going to, before I do that, I'm just going to check for any actual easy Sudoku, because you just never know what I might be missing. Well, you know, but I don't know what I might be missing. That hasn't changed at all. Okay, I'm not missing much. So let's, well, if I am, I can't see it still. What is the maximum value of those two? It's 11. What is the minimum value of these three? 315. It's 9. There are 2 degrees of freedom, and you can never take 1 out of this equation. So, I mean, I should actually just do some colouring of the green against the grey section there, and the purple against the bright blue section there. But there's 2 degrees of freedom. This could be 9, 8 or 7. There must be a 1 in these cells. And then the other number is going to be 2 less than whatever is in here. So it's either 1, 5, 1, 6, which it can't be, or 1, 7. So this can't be an 8 now. It's either 2, 9 versus 1, 3, 7, or 2, 7 versus 1, 3, 5. There's no 7 in these remaining cells. They're either an 8, 9 pair or a 5, 8 pair. One of them is 8. And over here, okay, this can't be an 8. So 11 is the maximum. The minimum for this group, the minimum for this group is only 8, 3, 1, 4. So that could be 6, 7 or 9. This pair, if they didn't have a 1, would be up to 12. That's too many. So there's definitely a 1. Now I've got an X-wing on 1s. That's going to use up the 1s between rows 2 and 3. And now none of these cells can be 1. And that is significant because I can take 1 out of there and put it here. I can also place 1 in box 1. There it is. And these two are going to be 2 less. No, the other digit that goes with a 1 here is going to be 2 less than the number here. So if this is a 6, this is a 1, 4 pair. Otherwise it's 1, 5 or 1, 7. That's quite hard to do anything with. Now, one of these is a 7. We've got that. That's a 7 X-wing with there. So I place 7 in the first row. That's now not a 7. This is 3 away, so it's not a 4. This is from 6, 8, 9. Now, can I do anything with this crazy long line? This cell can't be 1, 3, 7 or 6 or 4. So it's 2, 5, 8 or 9. This cell can't be 6, 4 or 7. It can't be 1 anymore because that can't be 1. So 2, 3, 5, 8 or 9. If you had 2s at both ends, those would be the same as each other. I've just noticed there's a 6 in one of those cells. I don't think we're going to get very far because I reckon these could be 9s with a significant overlap in the middle, which no, it would be those 5. No, I don't know. Those 3 cells would be the overlap in the middle. And then you just have to make the top 6. I don't know. There's a lot of possibilities between these digits. I'm not going to try messing with that too much. Now, maybe I should be doing blue against yellow, because I think that looks hard to achieve. This is either a 9-7 or a 7-5 combination. I don't know. Sudoku, there's a 3 in one of those. There's a 1 in one of those. There's a 4 in one of these 2. Now that's getting interesting into the blue and yellow cells. And we've filled this. So there is a difference between the blue and the yellow total of the difference between 11 and 4. So there's a difference of 7 between those. We're going to find out the parity of this. All of these cells are 45 minus 6. Now, the value of every box in Sudoku is always the same. It's 45. That's a secret, but you know it, and I know it. So we're going to use it. 45 minus the 1, 2, 3 in this box means these add up to 39. There's a difference of 7 between those two. So one of them's odd, and one of them's even. That is going to have to be even, and it sees 2, 4, and 8. So it's a 6. That's nice. This can't be a 6. We can't have a 4 up here. Now we've got the same situation. One of these is definitely a 7. Now, what can we do here? We can work out the calculation of the 7 difference. Okay, so this is going to be complex for me. 45 minus those 12 is 33. Take away 7, you've got 26. Divide it by 2, you've got 13. So I reckon these two add up to 13. These 3 add up to 20. And that's going to make the box add up to the right number. These 2 that add up to 13 can't have a 6 in. So they're either 5, 8 in that order, or 9, 4. These have a 7 in, which has to go here. And that 7 is the difference, so we've got another pair adding to 13. If that's 5, 8 or 9, this is 8, 5 or 4. And 4 is thus fulfilled into one of those cells. Okay, that's going to work. Now, if this was 5, 8, that would rule out the 5, 8 pair here. If it was 4, 9, it would rule out the 9, 6 pair. Oh, 6, 6, and that 6 says one of these is a 6. So actually the 8, 5 pair is ruled out. We remember that orange and green have to have a 3 difference. That's quite interesting. So one of those is a 6. 1, 2, 3, 6, 5, 7, 9, 4 and 8. Yeah, I don't know what that did, if anything. This is 3, 8 or 9. Oh, that's getting quite interesting too. Now, that is not 7. Where does 7 go in this column? I know that's not 7 because one of these has to be for the sum. So 7 in the column is down at the bottom. I wish there was some other digit. I knew that couldn't be a 6 before. Okay, that's not going to do anything. It was an interesting find in its own right, but that's all it provided. 1 has got to be here. We've worked out that can't be a 1. This can't be a 1 because there's a 1 there, so that's a 1. This must be 2 in the box, just by Sudoku. Now, this can't be 5. The total would be at least 21, and we're not going to get to that here. So that's a 2 as well. So 2, I mean. So they are the same digit at the two ends of the line. That means that this digit is the same as this one. We'll make them red, and these reds can forget because we've dealt with them. This is 6, 8 or 9. It can't be 6. So it's 8 or 9. So is that. That's an 8, 9 pair. This is 6 in the orange. Oh, this is a lovely puzzle. That's 3. And now this line must work, whatever else we put in. So I'm getting rid of those colours. 6 and 3 there. This is 8 or 9. This one is... Well, these add up to 13, don't they? So they don't have both 4 and 5. So this is 4 or 5 up at the top. That's 3 in box 2. Remove the corner mark. 8 must be in one of these cells now. So it's not there. and therefore this, which adds up to 13 with it, is not a 5. Oh, come on, do something. That... I don't know. As long as these add up to 13 and those do, we're obeying that line. As long as these reds are the same, we're obeying that line. As long as the digit with the 1 here is met by 1 too larger there, we're doing that one. Okay, so I haven't got much to learn from the rule set anymore, which is a relief, because it's been teaching me pretty hard up to this point. Yeah, I don't know. I'm just going to have to solve. Now, there's a 7 there, so there's no 7 in this pair. That's really straightforward. Sorry if you've had to shout that. So that gets me a 7 there. This colouring is unnecessary now. And we've got a 5 in that cell, so that 5 can't go down to there. Now, 31572. The trouble is, I just don't know what happens, what I'm meant to do as a result of this each time I get a deduction. I found 4 in the final column. That's quite unexpected. There it is. It's not here, therefore. So, yeah, one of those is 4. I can now see that. It was probably fairly obvious. Don't worry, Mark. Just take it nice and slow. There is no rush. I do want to get through it, but I want to get through it carefully and correctly, and I am prepared to wait till I can find the remaining breadcrumbs hidden in the puzzle. There is a 157 triple. Does that help? That is 4, 8, or 9 as a result. I don't know. I don't think the 157 triple did help, even though I know one of these is a 7. Oh no. Starting thinking about uniqueness and weird things like that. It can't be that hard now. Come on. That pair adds to 13. Maybe one of these pairs is tricky. So if that's a 5, 8 pair, and that's a 4, that's a 9. You get 9, 4 here. That's the powerful thing. Cannot see what's wrong with that. These are from 359. Let's fill that in. One of them is definitely a 3. 379241. That is 5, 6, or 8. Oh, that's a 4, 5, 6, 8. 1 is placed in row 5. Just didn't see that. I don't think it's going to do a lot else. This is 5, 6, 8, or 9. Might as well pencil mark the last 2 cells. 3, 6, 8 now. Just in case they show me something that's going on. I can't help wondering if I've missed a rule or something. But I mean, we're close to a finish now. I do want to do it. I really do. Oh, I haven't marked this one, which is interesting, because if I could keep 9 out of it, I'd actually have a lot of progress in box 1. 5 has to be in one of those cells in the bottom row, so that's not a 5. Now 5 has to be in one of these 2. And that is not interesting. Yeah, it's going to be something like that. So 6 I've marked has to be in one of those. The 5-6 pair. 5-6 pair says that one of these is 5 or 6, but not both. Is it time to start colouring 8s and 9s? And how is that going to help if I try it? Don't know. But there are a lot of 8s and 9s about. Yeah, maybe that is worth doing. So, okay, I'm going to remove all of these colours. I'm going to need this difference of 2 between those two. But red 8 or 9 is in one of those cells. Red is, of course, the same colour. Down here, that is the other colour of 8 or 9, so we'll make that bright green. So that's red. Eight and 9 are in those cells. Well, that can't be red. Where's red in this box? It's in one of those two. Do I know anything more about the colours, the numbers? I don't think so. I do feel like I'm almost onto something here, but not quite there yet. Whichever one of those is this red number. What? One of those is in this pair, and the other one is in this pair. One of these red and greens. The trouble is, I don't know where green is here. I don't know where green is anywhere apart from there. Oh, it'd be useful to know what its digit was. Can that be red? Then red would be a 9. If that was red, it would be a 9. If it was green, then the red in the row would be in one of those two, which would have to be there. One of these is red. Can the other one be green? Yes, I think it can. Oh, I can't see this. I think it's very doable. I'm not panicking. I just can't see what to do. Unless I've ruled out some cell as having any use to us in the calculations, and it actually does. But I don't think that's the case. I mean, this one is a joint number common between the two foursomes. I don't know what that does. 5 is in one of those. Seven is in one of those two. That's definitely a 1-5 pair. Now, what's going on with 4, 6, 8, 9? Why are these so randomly disposed? Don't know. Oh, this is driving me mad now. It's driving me nuts. If this was a 9, the 9 in the bottom row would be red. Then that would have to be the red 9. Red 9 would be there. Obviously is sitting there. then that would be the red 9. So that was based on this being 9. If that's 8, well, now that's interesting. So if this is 9, 9 in the bottom row is there, so it's red. If it's 8, that's a 3, this is a 6-9 pair, and that's 8. So it's always red. That cell is always red. Ah. Now this is the red 8 or 9 in box Jobby, box box whatever that is. That is the red 8 or 9. It's not 4 or 5, it's 8 or 9. Oh, this got interesting. Red 8 or 9 in column 4 is here and is a 9. Wow, that is mad. What a great spot on row 7, column 3. I mean, if you're meant to do that, I mean, I love it. I love the logic of that, but only because I found it. Not because, well, I mean, it is brilliant if you're meant to find it, but it's hard if that's the case. Right, these two added up to 13, so that's a 4. This is now 5 and 8. Oh, and we know these colours, don't we? In fact, I can get rid of all of these colours. Going to do that. It can restore the red. That is a 4. I thought I'd put that in. That's green. That's green. That is obviously a green 8. Now we can take out all the pen. I mean, it's going to be easy from here on in. He says, scared that it isn't. But I can take out a lot of pencil marked 9s. There we go. This is red, isn't it? That's just obvious. That's a 9. That is going to sort out 3 in row 4 as the last digit. That's not a 3. This is not a 9. Yeah, this is going to have done everything. I'm just going to patiently go through, picking off the numbers. Let's do greens. One of those is green. That's green. It's the only place 8 can be in box 1. That's therefore green. That's therefore green. And one of those two is green, and that is green. Let's start there. That's green, fixes this one. That's green, that's green. They are all 8s. And now we can surely finish off everything else. 6, 3, 5, 3, 5, 3. That's a 4. And we finally learned this one. The N on that line is 9. This is a bit similar to yesterday's actually, although there the lines were all different ends. I hadn't really thought about it from that point of view. 6 there, 5 there. 6 there, 4 there. Bingo. Oh, nearly an hour. Oh, that was harder than I was expecting, but that's good fun. That's a very clever puzzle by... Well, I mean, that's the pedaling pianist for you. I get to do the pedaling pianist this time, and I get to enjoy it a lot. So thank you very much for, well, for all your Christmas wishes that we've had. We are very grateful for any interaction you do with us. It just makes it always fun. And we love having you with us on the channel. Yeah, somebody commented yesterday that they hoped for our own sakes that viewers weren't being too needy or greedy, therefore we were doing a video a day. It's nothing like that. That's not the relationship. We don't regard ourselves as owing you anything, but we do like to bring you these brilliant variant Sudokus every day. And it's just fun for us to put them out there. Thank you very much for being with us, and Merry Christmas. There's the bobble again. And I'll see you tomorrow on Christmas Eve. Bye for now. Farvel Sørensen.